joint water pollution control plant in Carson. As the population grew in the 30s, 40s, the population and the development of communities spread to the north and to the east in Los Angeles County. And so we had the option of either expanding the facilities in Carson or putting upstream satellite plants, if you will, water reclamation plants upstream, and that's what we did. We had planning efforts going back to 1949, and I just want to read you a paragraph. Here's the 1949 report. It was published by the sanitation districts, county flood control, and also the county engineer. So here's travel back in time. The rapid depletion of groundwater supplies in the South Coastal Plain is a matter of grave concern to Southern California. The continual increase in water demands during the period from 1932 to 1944 alone by an additional 1 million inhabitants, and 1,800 new industries, but the latter with a capital investment of $170 million clearly indicates the need for conservation and reclamation of water from all feasible sources and its use wherever possible. That was their challenge then. It remains our challenge today. We do stand on the shoulders of giants, but there's a lot of additional work to be done, and we're excited about that. So as I mentioned, we built this system structure to provide recycled water with the plants higher up in the basin. Those plants began in 1962 with our Whittier Narrows water reclamation plant. It was the first water reclamation plant in the country to be designed specifically to provide recycled water for recharge, groundwater recharge, and we now have 10 water reclamation plants that you see in the orange dots there, except for the plant in Carson, with over 100,000 acre-feet of beneficial use each year. Water not sent to those plants, the more industrial type wastewater is sent down to our joint water pollution control plant in Carson, which has an ocean outfall for its treated water. This slide just shows the growth of our recycled water program over time since 1970. These are the number of reuse sites, and you can see here there's been a steady growth since the 1980s. And today we have our recycled water is being used at over 770 different reuse sites. The vast majority of the number of those sites are purple pipe systems where the recycled water is delivered directly for use through the purple pipe system. And here's just a slide that shows a wide range of potable uses. Irrigation of parks, of course, and schools, road medians, businesses, golf courses, and cemeteries. There are industrial uses such as energy production in the upper right corner. That's our Pointy Hills Energy Recovery Facility. Recycled water is used in carpet dyeing plants, used for dust control and construction, and cooling towers. Also, we use our recycled water for agriculture, primarily for us in the Antelope Valley. That's a closed basin. There's not a river for our treatment plants there to discharge to, so we send the recycled water to agriculture land to water crops. And then environmental uses, and a picture of that is in the lower right corner. And then environmental uses are things like maintaining habitat. There are limitations on using purple pipe, primarily the cost to build a separate pipe system. And if you're not close to a water reclamation plant, that can be very costly. There's variation in demand both throughout the day and also seasonally. So that constrains really where we can use purple pipe systems. This just shows you a breakdown of the uses of our recycled water. Again, we are able to reuse a little over 100 acre-feet a year, which is the equivalent of supplying about 200,000 homes. I'll start with the landscape irrigation in pink, and going clockwise, you see landscape irrigation is about 17%, small amount of industrial and environmental use. You see the agriculture use is 13%. And the vast majority by volume, I mentioned the purple pipe systems, that's the vast majority of the number of reuse sites, but the vast majority of the volume of our water is used for groundwater recharge. It's both the largest use, but it also has the best potential for new projects and growth, and it is less seasonal, obviously, than something like irrigation. It's got potential for growth, it's less costly than separate piping systems, and it will provide regional benefits. I'll talk about a few of the projects related on the horizon for our groundwater recharge program. Since 1962, the Water Replenishment District and the County Department of Public Works has partnered on groundwater recharge. So we've been doing groundwater recharge for over 50 years. The water is delivered by gravity to our spreading grounds, where it receives additional treatment through the soil aquifer treatment process. From an energy standpoint, it's the most efficient way to provide and add to the potable for potable reuse, since there's little energy required to let it flow to the spreading basins. We also provide water to the Leo Vanderland's water treatment facility, which is in the lower right, which provides microfiltration, reverse osmosis, and ultraviolet treatment, where the water is injected to the groundwater reservoir to prevent seawater intrusion. And that's operated by the Water Replenishment District. I think you're going to hear from them later today. I'll just touch on the project that Gordon mentioned to you. The biggest source of our untapped water is the water that's being discharged to the ocean from our Carson treatment plant. We currently process about 265 million gallons a day at that plant. We haven't done a project there other than research with MWD because of the industrial nature of the wastewater and the cost of treating that. But today the technology has come a long way and it's feasible now. But the problem is that there's limited markets for the water near the plant, and there's a lot of flow. And so what that means is you're going to have to convey the water to a wide regional area. And it just makes sense that a water agency such as Metropolitan is large enough that they have the resources and they serve the regional area to partner up with them on a project. So as Gordon mentioned, the immediate next steps are to have our respective boards consider a project. The first step would be a 1 MGD demonstration plant at the Carson facility, and concurrent with that, a feasibility study to look at the larger project that would be implemented in phases, as Gordon mentioned. Technology would be similar to that used in Orange County Water District and Orange County Sanitation District. I think you'll hear about that today as well. So as Gordon mentioned, his board will consider the proposal in November. I'm in the process of briefing our boards on the project, very supportive, and hope to take that to our board for consideration for approval in November as well. We're also partnering with other agencies on 2 other projects. The Groundwater Reliability Improvement Program, or GRIP, upper left corner. That's a partnership with Water Replenishment District. I won't say too much about that because, again, I think you'll hear about that later on today. It's an advanced treatment project to increase the recycled water that's going for groundwater recharge. Expect to be completed with that project by sometime in 2018. And then in the lower right corner is the Indirect Reuse Recharge Project, IRRP. It's a project with the Upper San Gabriel Valley Municipal Water District, which would involve additional recharge in the Santa Fe Dam spreading grounds as well. And they're targeting completion sometime in 2019. We're also working with our districts in the Santa Clarita Valley and the Antelope Valleys in the northern part of Los Angeles County for additional recharge and or recycling projects, but those are not as far along as some of the projects here in the LA Basin. So let me just touch quickly on both biosolids and energy. We started beneficial reuse of our biosolids produced in the treatment process from the very beginning at the treatment plant in Carson. We entered into a contract in 1928 with Kellogg for production of fertilizer products at an adjacent site. And this continued for many decades until the air concerns coupled with the urban growth around the plant that led us to other options. So we now maintain what we call a diverse portfolio of biosolids management. So we've looked at many options over the years, but the mainstay of our biosolids program has been composting for a sustainable soil amendment. You can see on this slide a variety of private composting sites and land application. If you look at in the bottom of the slide, the Inland Empire Regional Compost Facility, that's a facility that we co-own with the Inland Empire Utilities Agency. We took an abandoned IKEA warehouse and gutted it and built the compost facilities within the building. And both agencies send biosolids to that facility and market the products quite successful. If you look to the top, the Tulare Lake compost facility, that was a facility that's being constructed in the final stages of construction today. We bought about 15,000 acres of farmland from a long-term multi-generational farming family. We built a compost facility on that property and leased it to the farming family, so we'll have an on-site market for biosolids. So these are just some advantages in terms of sustainability that the biosolids compost produces. Soil Pro is the brand name of the material that comes out of our Inland Empire compost facility. Rich in organic material, so they improve the soil health. That's been shown to increase crop yields, help mitigate climate change by carbon sequestration in the soil, and reduces the need for irrigation, a number of the other items on the slide here. So let me just turn quickly to energy. It's long been our mission to convert the waste products that are byproducts of both our wastewater and our solid waste operations into some sort of resource, and that is consistent with our renewable energy program. So with biosolids, we started beneficially reusing the gas produced in the digestion process to run this biogas engine. This is a photo from 1938. And then that was at our Joint Water Pollution Control Plant. Today, we are completely energy self-sufficient. There are 24 digesters which stabilize and reduce the volume of the solids. The gas then goes to an energy recovery facility that produces 20 megawatts of power, and again, allows the treatment plant to be energy self-sufficient. The total production that we produce for all of our facilities is about 120 megawatts, and that makes us one of the largest producers of green power in the state of California. So those are some of the things we're up to in terms of sustainability, but I'd be happy to answer any questions, try to answer questions.
Thank you. Excellent presentation, Grace. Great blend from the past history to the current. I had a question regarding an area that's starting to pick up some steam, and that's with alternative satellite treatment plants and also gray water use. And I'm wondering, in relation to your sewer operations, your treatment operations, and those 770 customers that you provide water to, has your organization taken a stance on those who either reuse their water from their homes and businesses or mine the sewers to produce what typically is a good thing by reusing water? But I'm wondering how if you're tracking how it impacts your operations and reuse.
Well, I think in terms of gray water systems, I mean, that's at the discretion of homeowners in their local jurisdictions. I think conservation across the board is important, but for us as a regional agency that treats wastewater, that's just perhaps would complement what we do. But in terms of satellite plants and scalping plants, we have talked to various folks that have an interest in that. At this point in time, I think it will continue to be in the mix, but at this point in time, it's not as cost effective as regional facilities, and because of the economies of scale. So we haven't seen, I think there may be a number of the facilities where it makes sense throughout the county, but not widespread.
Very interesting presentation, thank you. On the purple pipe system, where you installed them, were those just new developments, or were you retrofitting existing buildings or homes?
So a lot of newer facilities going in will put in purple pipe if it's close by and available, and some cities even put it in hopes that the future of the water, they can send the water there. But a lot of this purple pipe system was retrofitted, again, back between the 60s, 70s, 80s, 90s time period. Groundwater recharge is more of our focus these days because it can serve a broader region more cost effectively and use the same water infrastructure. So both of them are needed, I think.
Just a follow-up question. So, you know, when you look at water reuse, you look at fit for purpose. And I was just wondering what level of treatment you do when you use the water for agricultural irrigation or irrigation of parkland.
It's recycled water standards, Title 21, never 60 piece.
Recently, there have been a lot of indoors water conservation efforts going on. Did you experience the lower level of flow going into your treatment plants because of that?
We actually, over the summer, since the real efforts and the dictates reductions were done, we have not seen a great reduction in the last, say, 6 months. We did see a reduction during the recession, and it sort of stayed steady there since then, and I think part of that's due to ongoing conservation and greater efforts, but just in the recent months, we haven't seen a lot yet.
How do you see the pervasiveness of 1,4-dioxane in the groundwater, and probably now a lot of your wastewater coming in to, say, your recycling plants? How are you going to balance that out in terms of its impact to groundwater recharge?
I'm going to say I can't answer that. I don't know if we have any staff here. Anne can handle that one.
We haven't really had big issues with 1,4-dioxane in our water yet. The amount coming into the treatment plants or coming out of the treatment plants is just slightly right at the current notification. Current notification of 1 per million. There are localized pockets of existing 1,4-dioxane contamination around various basins related to older industrial activities. But for groundwater recharge, we haven't had an issue with it. For direct injection of water, you're actually required to do advanced oxidation, where you bring down 1,4-dioxane before you inject the water.
Stan?
Mike Sheldon and Michael Grimm.
I'll just shout it out. I suspect you have a very positive answer to this, and maybe it's a joint question for you and Gordon. But has anybody looked yet at the energy component of the plan to reclaim water at the joint plant with the advanced treatment level and then the redistribution and that energy consumption in that plant versus pumping water, importing water from other parts of the state? I suspect it's a very positive balance, but I'm just wondering if you look at that.
Gordon might be better to answer that. It's something we'll be looking at as a feasibility study goes forward. But
thank you. I can say that the energy required to pump the reclaimed water from the joint plant in Southern California is less than what is required in the state projects as been bringing down to Northern California. So it is positive in comparison.
Michael, and then we'll move on. Michael,
Grace, that was a great talk. Ann Oaken would be proud, I think.
Especially since you came from the water supply side into the wastewater, so congratulations on that. My question involves the issue of conservation and its potential impact on the sewers. Several have suggested that there are issues that might result from much lower flows in the sewers. The Germans are having this problem. Is there any indication of this as a serious issue going forward?
We don't think so because we have such a great fall in elevation in our system that there's not as much problem with the wastewater going stagnant, if you will, in a fall system.
Okay, great, thank you. Thank you very much. And then the last speaker for this morning, making his way from the rafters here, is Marty Adams. Marty is the Senior Assistant General Manager of the Water System for the Los Angeles Department of Water and Power. You want to know something about their water system, you go to Marty. He's got more than 30 years of experience with LADWP. He's worked throughout the water system and was directly involved in the planning and implementation of sweeping upgrades centered on the removal of open distribution reservoirs and changes in the water treatment to meet new water quality regulations. He's a lifelong resident of the LA area and received his BS degree from Maryland University, and he's a registered professional engineer. And Marty, I don't, like Enrique and a number of professionals in here, I don't understand where you get all the hours that you do. Because Marty also serves on the Burbank Water and Power Commission, so he is out there. Marty, thanks so much for being here. Look forward to your talk. On the left. Top left. Way on the top, in the top left.
That folder is empty.
No,
I clicked on You got it, you got it.
Well, good morning. It's a pleasure to be here. So this is the extra time to talk. There's nothing like being the guy standing between a speech and lunch. But okay, perfect. All right. Good morning, everybody. It's great to be back here. I will tell you that when I graduated in 1984, this building wasn't here by a long shot. Ferrer Hall hasn't seemed to change very much. Besides trying not to hold everyone up with their stomachs are growling, I do have the advantage of hearing everybody else's previous questions, so I have a lot of answers for some of those things that were brought up. So I'll try to throw those in as we go. So I want to talk a little bit about what's Los Angeles doing for its water supply. I mean, ultimately, we talk about the wet infrastructure. We're obviously worried, near term about El Nino and flooding. We're worried about drought. We're worried about our systems that protect the environment, the sewage systems that handle the wastewater that we create, and how do we not only reuse that, but the primary function when those are constructed is to protect public health and protect the environment, from the effects of us living here and the waste streams that we create. Ultimately, the big question is, what are we going to drink? How are we going to be here as a city, as a community in the future? And so I want to let you know what we're planning to do in Los Angeles and how all the things you're hearing today kind of come together. So just real briefly, LA Water and Power, just like LA Sanitation, we serve the city of LA. LA is big. LA is almost 470 square miles, 4 million people here. It is a complex area. If you talk to people around the world, they generally regard the LA systems as some of the most complicated anywhere, and a lot of it's because of the elevation difference, and not only the elevation difference, they're changing climate zones and narrow passes. Oftentimes, we look for pathways to get water, and I think the same with wastewater, from the valley to the city, and you realize that you have the LA River Passage and you have the Cahuenga Pass, and you have Sepulveda Pass. And other than that, there's really no way over the hill to move utilities. And so it's a very interesting geography, very challenging place to work, but full of opportunities. So historically, the sources of water for LA, if you look at the lower left, originally we had local water supply, and that lasted till around 1900 when we realized that a city of 250,000 people, LA could not grow. And there was a move in the country to try to grow large cities, to try to develop the West. And so back in the early 1900s, the Los Angeles Aqueduct was built, and that's the long line going up to the right in the middle there. So the LA Aqueduct goes to the Eastern Sierra. That was the big William Mulholland project when he was a visionary for water supply for the city, and that's really what the city grew on. So when I started at Water and Power in 1984, 70% of the city's water supply came from the LA Aqueduct at the time. And then we bought about 15% from Metropolitan Water District, which is the Colorado River Aqueduct, and the State Water Project that Gordon spoke about, these projects and the water supplies. And about 15% came from our local groundwater. And this was the norm in Los Angeles. Although as early as 1970, we started looking at that and try to reconcile, how do we make better use of local water supplies and start conserving supplies. So the idea of looking internally at what we can do here in Southern California is very much in the forefront right now, but it's been going on for about 40 years in terms of our water planning. On a typical year right now, the pie on the left, we buy a little over half our water from Metropolitan Water District. And the reason we have to buy so much water is that our LA Aqueduct, that used to be 70% or more of the city's water supply, has had a number of challenges. We've had things such as the Mono Lake decision that left a lot of water behind in the Mono Basin. We've had water agreements with Inyo County and court settlements. We've had projects such as the Lower Owens River Restoration Project, which at 62 miles is the longest river restoration project in the United States. We've had dust control projects at Owens Dry Lake. And so a lot of things that have chipped away at that aqueduct supply, so that today we're only getting about half on an average year of the amount of water that we normally get down the aqueduct. And then our local groundwater has been somewhat confined because we're struck with our existing groundwater rights, and plus we're fighting contamination that's kind of chipped away at that as well. And so our purchases of Metropolitan Water District water have gone up considerably. So say 15% 30 years ago to well over half now on an average year. Then you take the chart on the right. The chart on the right is what happens in a drought. And of course, for Gordon and his friends, this makes him very happy because we're buying a lot of water. And so it's a great business model. But for the city of Los Angeles, this is very expensive. And we're paying about $350+ million a year to purchase water. And that's money that doesn't go into the city's infrastructure. It doesn't go into the city's water resources. It's money that leaves the city to buy a water supply. So we've found in the last, actually this is the last couple of years, a little over 70%. We've been as high as about 80% of our water for the city in the last couple of years being purchased. And so this is very expensive. Right now, about 39 cents on every dollar that's sent to the water department gets sent onto Metropolitan Water District to pay for purchased water. And so we have been pushing the wells recently in spite of some contamination issues. But we see that really our local water resources are a very small piece of the pie. And we're really reliant on these water supplies that we don't own and come from a long way away and also have their own set of environmental and climate challenges. Our plan for the future is to take advantage of more local supplies and what we do with conservation. So these are the big pieces. We'll go into a little more detail, but conservation is obviously a huge part of the city's water portfolio. You don't really think of conservation as supply, but supply that you don't have to put in the pipes is as good as the water that you do put in the pipes. Then we have stormwater capture, and I know Enrique talked about some of the aspects of that. I'll talk about how that fits into the water supply picture, additional recycled water recharge, and then remediating our groundwater basins. So up on the left is a picture, a version of the current mix on a typical year. So this is not the drought year, this is more of a typical year. We're about a third of the aqueduct, more than half met, and local groundwater. The picture on the right is where we're going to go. And so our mandate is by, actually it's 2035 now, with the mayor's directives now down to 2025, is to cut by more than half our metropolitan water district supply. We want to maintain our aqueduct supplies. We want to cut that net supply by developing the local supplies. And the local supplies would be our local groundwater, getting back the contaminated wells, increasing water conservation, adding a significant amount of recycled water, and then adding a lot more stormwater capture. And so, so this is where we want to go in the future for the city, and this is step one. There's a step two, and that's by 2040, we want to reduce this even further so that we're more locally reliant on water supply. In terms of conservation, conservation is an interesting story for the city. Right now, well, we've been saying for a long time the reason the same water is in the 1970s, although we have 1 million more people. Well, we're well below the 1970s. We're somewhere in the 60s, maybe approaching the 50s for water use. And if you saw in the paper and everybody said, I'm saving water, now you're raising my water rates, this is because when you are 100% commodity based, when we only make money on the water we sell, that as people stop using water and you have programs in place, you have mainline infrastructure being replaced, you have bonds to pay for capital projects, those bills don't go away. And so you have to have some level of revenue. And this is something that everybody's dealing with right now in the state, is what do we do as water agencies when we're selling less of the product, but the facilities to deliver that product have to be maintained and have to be improved over the course of time. But in terms of the history of the city, if you look back in the 80s, we had a huge gallon per person per day, 187 gallons per person per day. This is our GPCD. And then as early as the 2006, 2007, we've done a lot of conservation efforts, mostly indoor conservation. We're down to about 156 GPCD. And then by 2013-14, this is kind of the early stages of the drought. We had mandatory conservation in place since 2009, and we reduced by about 16% our demands. So about a year, actually right about a year ago, we were at 131 gallons per person per day. And at that point, we were pushing amongst the lowest major cities in the country. And then the mayor gave us a challenge to reduce our demands even further. So the green lines are our demands, what's happened since the mayor's directive. And we are increasingly, well, decreasingly, using water through the city. We're now actually at his demand for the end of this calendar year. And by the end of next calendar year, we'll be pushing that demand even further. So water conservation really works. Now, key things about this. Some of this is habit and asking people to save. Some of it is laws mandating how people do and don't use their water. For instance, we may change the number of days people can water at your yard, but we'll never say it's okay to wash down the sidewalk again. That'll be illegal in the state of California probably from here on out. So there are prohibited uses that will continue in society. And then there's a lot of changes. We've had changes in our indoor water use through more water efficient fixtures, and then we've had changes in outdoor use, a lot of it going to the whole turf replacement program and kind of a changing of the mentality